now, before I pass it to Sierra, I would like to introduce her. I'm a big fan of her. Sierra is a software engineer at Clubhouse, based in Cincinnati, USA, focused primarily on native Android. She loves building beautiful and accessible Android apps. She's also beautiful too. Sharing knowledge with the community and mentoring aspiring mobile developers. She's a Google Developer Expert for Android and serves as the Director of Women Who Code Cincinnati, Director of Technology for Get Women in Tech IT, Women Techmakers Global Ambassador, and former Global Leadership Fellow of Women Who Code Mobile. Also, like, she onboarded me too for Women Who Code Mobile. I'm so happy to like work with her and know her. So I will now pass it to Sierra. Thank you again for Sierra coming today and sharing your knowledge with us. I will close my camera, but I will be in the background.
Perfect.
So if you need me, please let me know.
Amazing. This is fun to be on the other side of the event planning for Women Who Code Mobile. Okay. Awesome. Today we're going to be going through Unit 5 of the Android Basics with Compose course, which is connecting to the internet, getting data from the internet, and loading and displaying images from the internet. And when Selen asked me to do this, I was like, yeah, of course, no problem. I know how to get data from the internet. I know how to display images, no problem. These are things I know how to do. But this section had a lot of information and a lot of concepts. So we're going to go through some slides while we do a couple of the code labs today to kind of pull together how each of these different sections that were really focused on different concepts are actually used to do these two like fairly simple things in Android development. They're built on a lot of different concepts that we need to understand so that we're writing our code in a good, clean way, and following best practices and understanding what those best practices are and why they are the way that they are. So inside this get data from internet, we have a couple different sections. So this is a 5-section module where we have our video. We have an introduction to coroutines in the Kotlin playground, introduction to coroutines in Android Studio, an introduction to HTTP REST, and then finally we were able to actually get the data from the internet. We're actually going to be focusing on doing this get data from the internet, but as we hit those concepts, we'll jump over and review some of the information from these first couple of sections. So to do that, I think I already, let me move this onto this screen so I can see it. The dance of getting on my windows where I want them. We're going to get started with looking at this get data from the internet. So we'll go ahead and open that code lab, which you can tell I was doing because it started at the end. And so, like it says, most Android apps in the market connect to the internet. It's a very core functionality and it's really important. And it's almost always one of the steps that you have to complete for most Android interview challenges. The most common one I've ever seen in my career is getting data from the internet, displaying a list of data, clicking on that data, showing us some details about that item. And so having a good fundamental understanding of this is going to be a really important first step to getting your first Android job. And so what we're assuming when we kind of jump into this is the basic knowledge of composable functions. So we're going to be building a compose app, the basic knowledge of the view model, and the basic knowledge of using coroutines for long-running tasks. This is the bullet point. We're going to go spend some time in a PowerPoint to kind of walk through some of those core concepts around compose. And then the basic knowledge of adding a build dependencies to our build Gradle. We should have learned the other 3 data points as we've kind of worked up to this this unit of our Compose Basics course. So getting started, we're going to be working with an app named the Mars Photos app, which is going to show photos of the Mars surface. And a fun fact, I have a talk on getting started with Jetpack Compose, and it is also built around a Mars API. So that was very exciting for me. I've seen a lot of photos of Mars as an Android engineer because NASA also has a really great API that you can use for building apps. And so this is going to connect to the web, retrieve and display some Mars photos. And these are real-life photos from Mars captured from NASA's Mars rover. This is what we're going to be building up to, but we're going to be starting with this really simple application. In this part of the code lab, where all we're going to do is connect to the internet, pull those data down, and display a little bit of text on our screen. So with that, we're going to go ahead and get started. I already have this pulled up, and so we can jump over to my Android Studio. And now I have to change where my windows are. If I can find what I'm looking at. Okay, so and we can just kind of look around and see what we have set up already. So inside this project, first we have a home screen. This is going to display right now all of our results for this app. It just has a basic results screen in our home screen that has our Mars UI state. That is just a string. We can also run this so that we can see it in real time. We have a view model that's going to manage our state, that's going to populate our screen. And we have a function get Mars photos, where it's going to set the Mars photo API status here. And so in our screenshot, we see just that single string being set, which makes sense because we're setting that to our state. We're calling this in our init. It's flowing up to the screen, and we see that in the UI. Beyond that, we just have our photo app that is calling our home screen, and we have our main activity, of course, that sets all of this content in our app so that when we launch, we show this UI. And that's really all we have so far. So the first step that we want to do is start getting started with the web services. To get started with the web services. And so in this code lab, we're going to create a layer for our network service that communicates to a backend service and fetches our required data. We're going to be using a third-party library called Retrofit, and Retrofit is industry standard. It's what I have used for all of my networking and all of my roles since I started doing Android. And so this is a really good example of Google reaching out to the community. The Android community is always very vibrant. That's why we're all here. To use one of those open source community libraries to get started with our networking calls. Following good Android practice, we're going to kind of break this up into different layers. And so our view model is going to be responsible for making those network calls in our application. And so when we make that call, we'll update our state, and that will flow into our UI. So what we know though, is that network calls are not going to be synchronous calls. When you reach out to the web server, so when we look at our code lab and look at our web services with Retrofit, our application is going to talk out to that server and say, hey, I would like some photos. Can you please send those back to me? And then after some amount of time, that amount of time, we don't necessarily know how long it will be, those are going to come back. And so this is what we mean when we're saying like a long running call is when we need to use coroutines. And so in order to set up these calls, we first need to understand the coroutine concepts from some of those other sections. And so we're going to jump over and start talking a little bit about our coroutines to get started. So what you kind of get started with, and what you've really been doing through all of these sections before you got to networking, is you've been doing a lot of synchronous coding. And in synchronous code, only one task is ever in progress at a time. You can always think of these as just executing sequentially, and as one line finishes, the next line will start. And so if we look at this really simple main function, we have print line weather forecast, print line sunny, and we can all guess exactly kind of what's going to happen when we run this main function. Its print line is going to be a synchronous call. Because it will immediately print out the text before you can execute the next line of code. And the entire function main is also a synchronous function because we go line by line, and then once all those lines are finished, the function completes and it's fully complete once those two lines are run. And so when we run this function, we get out those two print lines, we get weather forecast, and we get sunny. And then the program is done, the main function ends. Now, we want to kind of pretend like we're making a network call. And like we just said, a network call is not going to immediately come back. And so instead, we can think about it having some kind of delay. So in this example, we start with this 1000 millisecond delay, so a 1 second delay. And what we know from going through these code labs is that delay is actually going to be a special suspending function. And so this is part of our coroutine library function. If we tried to run this immediately, we would immediately get an error that would tell us that this suspend function delay can't be run inside main because it can only be called from a coroutine or another suspending function. And so for the purpose of our code lab and keeping it simple, before we dive into coroutines and suspending functions in our Kotlin code or in our Mars app, we can just wrap this main function inside a run blocking block, which is another function from this coroutine library that runs an event loop that's going to be able to handle multiple tasks at once. And so each task can continue where it leaves off. And so now when we run this main function, we'll have this run block that's going to let us have this loop. And so we'll print line weather forecast. Then, as we can guess, we will delay for 1,000 milliseconds, and then we will print sunny. And so the output between these two is exactly the same between our first function and our second function, but the difference is the time that it's going to take to execute this. It's also important to note that this code is still synchronous. It's going to run straight through line by line. So it's going to first print weather forecast, then it's going to hit that delay. That delay is a suspending function. So it will wait, we'll suspend for 1 second, and then we'll go on to the next line once that delay finishes executing. And we call that second print line. And so we still are going line by line through this function, even though we're in this special run block. When we're thinking about coroutine, the co in coroutine means cooperative. And so the code is cooperating to share the underlying event loop that we just said, either a coroutine or this run block are creating for us. And when it suspends to wait for something like this delay, it allows other work to be done in the meantime. And so co and routine means cooperative routines, where routines just means some set of instructions like a function. So we can take this a step further and do a little bit of refactoring. And so we no longer want our forecast and we don't want our main function to hold all of our logic. We want to break it out into readable pieces. And so here we're going to break out that delay and sunny are into a print forecast function. And if we again tried to run this, we would again hit the same error that delay has to be called from a suspend or a coroutine. And so looking at this code, it might not be intuitive why this is the case, because we're still calling print forecast inside the run block, which means it's already inside this coroutine scope that we need. But delay doesn't know that because it's scoped inside this print forecast function, and that print forecast function could be called from anywhere. And so in order to denote that this is, again, this special function where delay can only be called from inside a delay or inside a coroutine or a suspend function, we add that suspend keyword to our function signature to denote that delay is a suspend function. For print forecast has to be a suspend function. And that way we can guarantee that print forecast and therefore delay will only be called inside a scope where it can actually execute. A suspending function is going to be just like a regular function, but it can be suspended and resumed again later. And so to do this, suspending functions can only be called from other suspending functions because it guarantees that that capability is going to be available. And so if we now think of this as adding a second function that's going to be print temperature, it's going to be just like our print forecast, a delay, a suspending function, and then print a temperature. We can now run these, and the total amount of time it's going to take is now a little bit over 2 seconds, but it will still go through line by line. It's still going to execute very synchronously because we have no reason to do these in parallel. And so it will first print line weather forecast, and then it will go to the next line. We'll break out, we'll go into that function that we created. We'll delay for 1 second. We'll print our forecast sunny. We'll come back, that has returned. So we can go to the next line. So we'll go to print temperature. That will delay for 1 second. We'll then print the temperature, and then we have hit the end of our run block. We'll hit the end of our function. Everything will return, and we'll exit that function. And again, the total time that this is going to take is about 2 seconds because those two different delays are going to happen sequentially because this is synchronous. However, we have options to launch these in parallel and break up the kind of work that we're doing. And so continuing on this thing, we still have this run block, and now we have our print line with weather forecast, and we have two new important functions, these launch. And so we separately put launch for print forecast and launch for print temperature. In doing this, we're going to get out the same output. This whole thing is a game of the same output and timing, but this time if we ran it, it would only take a little bit more than 1 second. And the reason for that is because we'll first print line, and then launch will create its own coroutine scope that does not necessarily have to print sequentially. And then after, it will delay for 1 second, print out the forecast, but separately, it will have already moved to that next line because we're inside this launch, and create a second child job where we do print temperature. That also has a delay of 1 second, but now these are being run in parallel, and so they are not happening sequentially one by one, and so we don't have to add those two delays together to run this function. And so while the output is exactly the same, it's now going to only take a little bit more than 1 second because those two delays are happening in parallel. If we added another print line at the end of this function with these same two launch blocks, we would be able to see that this is happening a lot more obviously. In the last function, it was only obvious if you were keeping track of how long it was taking because you were still getting out the same output. But if we add this extra print line, the output that we're going to have back is first that weather forecast, have a good day, then sunny, then 30. And so this is in the order that we see on the slide before. The first thing that we see here is print forecast. But now when we launch this, we'll launch and forget and print forecast. So that starts its 1 second delay. Again, these are not synchronous functions. And so we immediately go to that next line and launch a new scope for print temperature. That will start its 1 second delay countdown. And then we immediately again move to that final line, print line, where we have print a good day. Now there's no delay here. Those two delays are already going in their own scopes, and so print line can immediately print out. And so that's how we get from weather forecast to have a good day. Then we wait for that first delay to finish, we get sunny. We wait for our second delay to finish, we get 30. And now we can see how we get from these launch blocks, which are asynchronous, into this final state. Now, in the real world, we won't always know how long it's going to take for a network request for a forecast or temperature to take. Here we know it's always going to take exactly 1 second because we're putting a delay for exactly 1 second. That means that in 2 seconds, I know for sure I should have back both of these network calls, if you will. But if we want to display both the weather report where we have the forecast and the temperature, we can combine our launch approach. Our launch approach isn't going to be sufficient, and so we're going to have to use other features of the Kotlin coroutine library, specifically async. And so async is going to be a function from, again, the coroutine library that if we care about when a coroutine finished and we need a value from it, we can use async and await to retrieve this value. The async function is going to return an object of type deferred, and that deferred just means that the result is deferred to the future, which is a lot like a promise that the result will be there at some point when it's ready. Much like me showing up for my plans. I'll be there when I'm ready. You can access this result on a deferred object by using this await function. And so here we're going to update these print forecast and the get temperature function. Really, it should probably be get forecast, where we still have a suspend function, but this time we're going to be returning a string. And so this one still has a delay, and that's still in the future. And right now it's still hard coded because we're still in these like very simple examples of just understanding the coroutine concepts. But the only thing that we've changed in these functions is instead of having a print line, we're going to return that sunny and temperature directly. And so we can combine these new functions, these updated functions that we just created with async. And so we see here that we have our val forecast. So this time we notice that this is setting a variable and not just calling a function. And so we see that the forecast is now this type deferred string. So we just talked about how async returns this deferred. That's going to act like our promise. And string tells us that the type that it's returning will eventually be a string. And so same thing for temperature. So that deferred and the template type, this string here matches the return type of the functions that we're wrapping async in. And so once we have those and have those two asyncs, we now have this print line where we had forecast.await. And so that's going to wait for our forecast to be returned, and our temperature.await, which is going to wait for our temperature to be returned. And so that print line won't execute until we have both our forecast and our temperature returned, which in our case should be about a second. And so with this code, we would get weather forecast, sunny and 30. That's going to be our print line here. Our print line right here, where we have forecast await and temperature await, and then finally have a good day. And so what we're doing here is that we're creating two coroutines that are running concurrently to get both our temperature and our forecast data. And when both of those are completed, they return a value, and then we print those to that single line together. We can take this example a step further and see how coroutines can be really useful to do work in parallel. This is going to involve taking a problem and breaking it into smaller subtasks that we can then combine those subtasks when we're ready into a final result. And so if we look at something like this, we can now update and introduce one new function, still a suspend function. We'll introduce our getWeatherReport, where we create a coroutine scope, oh my gosh, which is going to create this local scope for our weather reporting task. This coroutine is launched within this scope, are all going to be grouped together within this scope, which has implications for cancellations and exceptions, which we'll learn about in the next couple slides. And so this is going to print out a really similar thing where we have our forecast. We're going to wait for our forecast. We'll wait for our temperature. We also notice here that we have gotten rid of the very explicit types because Kotlin can infer that for us. And so we don't have to explicitly say that forecast is a deferred type of template string. And we'll still return a string here, which is going to be the forecast and the temperature. And so when we run this code, we'll get our weather forecast. We'll print out whatever is returned from our weather report, which we know will be sunny and 30. It's the only weather report we have today, and have a good day. And so again, the output here is the same, but we have some important takeaways that we can do. As we mentioned earlier, this coroutine scope will only get returned once all of its work, including all of the coroutines it's launched, have completed. We only had two coroutines that we launched, get temperature and get forecast. But we could put more in there if we needed to. And so both of those coroutines have to finish and return their respective results. And then the sunny text and 30 degrees text are combined and returned from that scope. And then we can move on. With coroutine scope, even though the function is internally doing work concurrently, it appears to be synchronous because coroutine scope won't return until all of the work inside of it is done. And so the insight here is for structured concurrency is that you can take multiple concurrent operations and put them all in this single synchronous operation where concurrency is just an implementation detail and no one outside of that has to know. The only requirement for calling this code is that it has to be called in a suspend or coroutine function. Other than that, the structure of our code it doesn't really matter, and we don't have to take it into account for the details. And so that's going to give us like a really good baseline of kind of how all these different coroutine functions work. There's a few that are Android specific, but there are a couple of high level concepts that we can pull out of these. And so the first thing that we want to just like note is that when we're executing this work asynchronously or concurrently, there are questions that we have to answer about how that work will be executed and how long it should exist and what happens if it's canceled or failed with an error and more. And these become more important questions to answer if you're doing it in Android specifically, right? On Android, we care about your battery life. We care about not running things in the background. We don't want to pull sensitive data if you don't need it. We don't want to be running parts of the app and heating up your phone or doing any of these things. And so we want to be really mindful of these kinds of jobs. We don't want to be doing things we don't have to be doing in a mobile application. And so making sure we cancel and end all the work that we need to do when we should be doing it is a really important concept. Coroutines are going to follow the principle of structured concurrency, which is going to enforce us to answer these questions using a combination of mechanisms. So we've talked about this launch function. We've seen it at a high level. We kind of know how to use it and we kind of know how it works. But what you need to know is that when we launch this coroutine with the launch function, it returns an instance of a job, and that job holds a handle or reference to the coroutine, so you can manage the life cycle. And so we see here that if we did, this launch function will return a job, and so we could actually catch that job. This is something that I do a lot in the code that I write to go and cancel things behind the scenes. And so once we have that job, then we can manage its life cycle and call things like job.cancel when we're done with that task. And so if you think about something like a life cycle on Android, while many of these are handled, there might be things that you would want to cancel when the application lifecycle is over, the screen lifecycle is over, or so on and so forth. With this job object, you can check if it's active or canceled or completed. The job is completed if the coroutine or any of the child coroutines inside of it have completed all of their work. And when we talk about child coroutines or child jobs, those are just ones launched inside of the parent coroutine. So if we think about some of these functions that we looked at, going the wrong way, run blocking, we said is a coroutine scope. getWeatherReport is also a coroutine scope. And so this getWeatherReport is a child job inside this main run blocking job. And so run blocking can't complete until getWeatherReport completes, ends, throws an exception, or does something that would cancel that. This job is going to have control of the life cycle, or how long the coroutine lives for. And so you can always cancel if you don't need a task anymore. And what we've already said is that coroutines are typically launched inside this coroutine scope. We've used that word several times. And this ensures that we don't have coroutines that are unmanaged or get lost, which could waste the resources on our device. Both launch, this function that we've been using, and async, the function that we used to wait for that data to come back, are extensions off this coroutine scope. And so they're both going to create a new coroutine scope when you call either of those functions. Our coroutine scope is going to be tied to the lifecycle, which sets bounds for how long that coroutine is going to live within that scope. And this is where we get into a little bit of Android specific things and how we manage. And a lot of this coroutine scope, while it's really complex, can just be managed first behind the scenes in Android development. And so if you read through this, you might remember learning about the lifecycle scope, which is a really special well-defined scope that is tied to an activity or fragment lifecycle, so that you can launch coroutines in those views on Android, and they get canceled for you automatically when that activity or fragment is destroyed. Similarly, we handle a lot of our business logic and a lot of our functions inside our view model in Android using MVVM or an MVI. And so there's also a special scope called view model scope. And so when we launch inside a view model scope, which we'll be doing a little bit later, coroutines are start within that view model, and they'll be destroyed when the view model is destroyed. And so this means we can wash our hands of most of this as long as we follow good practice, use the right scope for the right place, and are really mindful of canceling any coroutines that are outside those scopes. The last thing that we want to call out is that the second kind of activity inside our coroutine basics and our getInternet is going to go a little bit more in depth into coroutines in Android. And the core takeaway here is that if you're trying to launch a coroutine inside of a composable function, we have to use a special launched effect to do that safely. And this is going to manage the lifecycle of that coroutine really similarly to how lifecycle scope does, or this view model scope does, but it does it for a composable function. And so this most of the time in my experience, I use view model scope the most because, again, most of our logic ends up being in the view model, but there are some composable functions where you occasionally need launched effects to handle your different coroutines. And so once we have this, we can use keys to let, similar to how we handle recomposition in Jetpack Compose, which you should have learned about in one of the earlier code labs, is that in this example, player 1 and player 2 are keys that let the launched effect know when they need to cancel and restart the coroutine based on the changing state of that composable function. And then inside that, you can launch coroutine scopes. So here we launch 2 coroutine scopes with 2 more child coroutine scopes with that launch like we just talked about. And so this is one way to do it and manage that coroutine scope inside a composable. The launched effect function enters composition. It will launch the coroutine that's in that code block. And then it will cancel that coroutine when it exit composition or when one of our keys change. So from here, now we have I forgot to put the Colab. So now we have this like really good understanding of how asynchronous calls work on Android. And so now we get to actually implement one. And so while we were talking about in our introduction to coroutines and Kotlin Playground, we were like, oh, we're going to pretend we're doing network calls. Now we're actually going to do that network calls where our delay is not just a hard-coded 1 second. So let's jump in. So the first thing that we need to do is add a couple of new dependencies to our project. So we'll go ahead and add in our 2 retrofit dependencies, which are going to be the library that we use to make these network calls, like we already said. And so we have our retrofit dependency and also our converter dependency. From there, we can now start setting up our networking classes. And so this project is already set up where we have this UI package inside Mars Photos. And so we're going to add a new package. We will, if I can remember where it is, new. We'll add a new package, and that will be called network. And inside here, we're now going to also make a new file, and that will be called our Mars API service. I'll just make that a class. Oh, I didn't spell it right. Refactor. Can't leave spelling errors behind. And so inside here, the first thing that we're just going to snag from the code lab is just our base URL. And so this is the URL that we're going to use to get these Mars photos. There are 2 different URLs that we could reach out to as part of this code lab, and I already have those pulled up. So first we have Android Kotlin fun Mars server.appspot.com/photos. So this is one endpoint that we could hit. Or we similarly have Android Kotlin fun Mars server.appspot.com/real estate. So there are 2 different ones we're going to hit. We're going to get started with the photos one, but it's a good challenge to also set up the real estate endpoint as well. And so what we see from both of these different URLs is that we can see the base URL when we're looking at this. We have Android Kotlin fun Mars appspot.com/photos. And similarly here, we have the same base URL/real estate. And so that's where our base URL is going to be coming from for our retrofit. It's everything that's the same across those. So the Android Kotlin fun Mars server.appspot.com. Next, we're going to create a retrofit builder. So we'll do our val retrofit. I'm very nervous about spelling errors. Retrofit.builder. And we're going to add a couple things to this. First, we need to tell the builder, really retrofit, how it can react to the data that it gets back. And so this is where we're going to use that converter factory. And so this scalar converter factory, scalar, I can't do both at the same time, read and type. This is going to let it know that we're fetching JSON from the server, but it's just going to be able to parse that and put in a giant string. And so that's all the scalar converter does, is creates a string from that response. Next, we actually have to tell it what base URL we want to use. And so we already have that set up. So we'll pass in our base URL, and then we can go ahead and build our retrofit instance. We're going to pair this with an interface. And this interface is how we're going to actually create all of our networking layer. And so from here, we're going to create our Mars service. And we're going to start with a single function called getPhotos, because we already said that's the endpoint we're going to hit. Getting data from the internet, there are different actions we can take. We can get data. We can post data, which is sending new data to the server. We can put data, which is updating data that already exists, or we could just delete it altogether. in this case, we already kind of have it in the name, is that we're going to be getting data from the server. We're not updating anything, we're just displaying. And so we're going to use @get as the annotation to let Retrofit know that this is a get action of those kind of 4 REST API actions. And so similarly, there's an @delete, @post, @put, and some others, I think. And so here we're going to add, what we're going to add behind that get is the rest of the URL that we care about. So we are starting with this base URL, but we had just looked at those 2 different pages. And so one was /photos and one was /real estate. And so we're starting with the photos one. So this is going to tell us that we're doing a get request with this base URL / whatever's in parentheses. And so in our case, that will be /photos. Retrofit is going to have a lot of support for other kind of URLs. This is a really simple one, but you're able to pass in URL parameters and bodies and do all sorts of things with just a couple of different annotations that will tell Retrofit all it needs to know about those network requests, because this follows a really clear REST API pattern. And so they can make all of the assumptions on the HTTP client, and all we have to do is tell it a couple different annotations and strings. From there, we do want to return strings from the service, so we're going to do string here. We said we're going to start with just pulling down a string. And then the last thing that we have to do is create a Retrofit service. And so in this file again, we will also add an object, the Mars API, and do our val Retrofit service, which is going to be a Mars API service, which is just an interface. And then the implementation is going to come from Retrofit itself, where we take, not Retrofit service, Retrofit, which is the Retrofit builder that we created, and do create, and then pass in this interface. And from that, it can do all of the networking for us. Yeah. Oh, I forgot the word lazy. Here we're following this object singleton pattern, which they call out in the code lab is not a pattern people usually follow. And so in the next code lab, you go through dependency injection to replace this with a better solution. So we know that we want to call this function from our view model. And so we can jump to our view model and now replace this get Mars with our new val list results and do our Retrofit service Mars API service get photos. Now, so far you might be saying, Sierra, we have not talked at all about coroutines. And that's a really good point. What we know is that get photos is not going to return immediately. We already know that. We've already talked about how network calls behave. And so what we need to do is come back and add suspend to our get photos. And if we come back to our view model, we'll see that we immediately get an error when that happens. And it will tell us our favorite error. This can only be launched from a coroutine or a suspend function. And so we're going to take advantage of one of those built-in functions and do a coroutine, the viewModel.launch, so that our coroutine is scoped to this view model and will only exist in this view model to launch our get photos function. And once we have that, we could just go ahead and display. Now, when we run this, this will immediately crash because we haven't handled the internet permissions. Often a joke on Android Twitter, RIP, maybe on Android Threads, but everyone forgets the internet permission the first time, and it always immediately crashes. So adding in our permission to say, hey, our app can reach the internet, we get back all of our results, and so now we are pulling that data from the internet. But what we're doing here is just showing strings on a giant string. And so in order to get ready to actually display these photos, we actually need to be able to parse these and deserialize these. And so we have to jump back into our build Gradle and add a couple more dependencies to fix that. So the first thing that we're going to do is here, add a couple plugins to work through that. So we'll add our serialization plugin. We will add a Kotlin serialization dependency. And then we also can remove our scalar because now we will be converting it directly into a Kotlin object. And so we can get rid of this bad boy. And not do that. And drop in our new dependencies. And then we need to sync everything, as always. Now, from our network response, we can kind of see how this object is gonna look. These brackets always means that you're gonna have a list. These curly braces always mean an object. And so here we're gonna have a list of photos. And so each one of those photos is going to have an ID. That ID is a string, and it's going to have an image source. That image source is also a string. And so now we can build the object that we want to parse this into. So we'll add a new Kotlin class here, and we'll call it Mars Photo. And we'll make that a data class because we are Kotlin experts and we love data classes. And so we'll have here a val and ID. That's a string. And a val image source, and that's also a string. Now, this is where we're going to take advantage of some of those dependencies that we brought in. So the first thing that we need to do is actually let it know that this is a serializable class. So we'll add our @serializable annotation. And if you've written enough Kotlin, you know that Kotlin folks, we don't like these underscores. We don't like snake case. And so we can also use serial name to fix this. And so when we use this @serial name, it's going to create a converter for us from this JSON into this object that says the name in this JSON data is going to be image underscore source, but I'm going to map that into my object as image source with the camel case we love. So now that we have this class put together, we can now again swap out our converter library. We already removed it. If we go into our Mars service, it's already upset with us about that. And so we can swap that out for a JSON converter to convert that into the actual type. And so here we'll go ahead and remove that, drop in our new JSON converter as converter library, do a bunch of imports, remove this. Must have a parenthesis wrong. Okay, yes, I do. There we go. And we're good to go there. So let's go ahead and run this. And this time, instead of seeing the direct JSON, we should be able to see kind of our classes as a giant string. Oh no, I did it too soon. That was my crash from earlier. What's this crash? Oh yes, got too excited. So right now we're still returning this giant string, but now we can swap this out because we're converting them to an actual object. And so now we can do our list of our Mars photos. And so if we go into our view model, we'll just do toString so that then we can see these objects instead of just JSON. And so now it's a pretty trivial change. Is that now if you look at here, you see that this says Mars photo, that matches our class name. These are now classes, although they still have exactly the same information. It's still just like a giant block of text. But this gets us most of the way through our first code lab, where we now understand how to connect to the internet. From here, if we jump back over to our code labs, we've actually ended through our get data from the internet. And so we're moving on to the next piece, which is loading and displaying images from the internet. We're again going to skip this add repository, and we're going to look at loading and displaying images from the internet, and we're going to try to do it in about 5 minutes. But first, this step number 2 in this video, a really great way to kind of familiarize yourself with modern Android best practices. And so I've put together a couple of slides to go through what they're going to be doing in this section, which is right now we only have these two layers. We have this view model, we have this weird singleton pattern, and we need to really break it up into this data layer. And so in this code lab, they're going to help you refactor to take this and put a repository in a date to attach to our data source. Separating our code out like this into different layers is going to make our app more scalable, more robust, easier to test, which is really important. And so having those clearly defined separation of parts and layers is just going to make it easier for multiple developers to also work on that project at the same time without negatively impacting each other. And the work that they do here is aligned with really Android's recommended app practices and is really similar to the architecture that I've used in most of the apps that I've worked on. And so our repository class that we're going to add here is going to expose some of the data from our data source. In our case, we only have one data source, that one network entry point, to the rest of the app, centralizes those changes. It might have some kind of business logic to translate data, and it abstracts the data source away from the rest of the application so that we could potentially switch it out. And so right now we have this Mars view model that goes straight to the data, goes straight to that data source. And after we go through this code lab, we would have this Mars view model, Mars photo repository, and the data. And so to actually do this, all we're going to do is create this really trivial little photos repository that's just going to have this get Mars photo. It's still going to be a suspend function, and it's going to be the one that now talks to that retrofit service. And in order to do this and inject that into our Mars view model, because we now need access to this repository, because we can't just pull from that singleton directly, we just have to set up a view model provider factory. It's just a little bit of Android boilerplate. And so we're not going to dive super into that. Once you've done all of this, then you're going to be in the kind of the final section of this before all of the practice projects that I recommend doing, which is going to be loading those images into the internet. We'll be starting now from the app that they've already built out. So I'm just gonna jump over to that one on our project. Drop everything we've done so far. We'll check out mine on. And then we can run that app again. From here, we're going to add some Coil dependencies. I think we're just going to walk through this because I can't type quite fast enough. Is that this Coil is a image library that helps manage your image cache. Downloading images from the internet in and of itself is not a super complex task, but there's a lot of things you want to consider. And there's, again, a lot of performance and storage issues that you want to think about. You don't want to download the same image twice back to back just because you navigated away and came back. And so that's what a lot of these image libraries give to us. They optimize, they cache, they do really nice things. And so we're going to add this Coil, which is a way to download these images from the internet. And we're just going to update our UI a little bit. Right now, we're going to be starting with a really simple app that just is kind of where we left off. We're getting these photos. We've updated our state just a little bit, but we're still just mapping those into our object. And what we're going to do with those is first add this async image. This async image is going to come directly from this Coil dependency, and it's going to do what it says. It's going to asynchronously load that image from the internet. And the really nice thing about this is it has a lot of nice features that you can take advantage of. For example, setting a placeholder, setting a content description, because we want our app to be accessible to everyone, telling in how that image is going to scale, which is exactly the same as how we do with an image view, as you have the same kind of content scale types, crop, fit, do these sorts of things. We always have our modifier, so we can put backgrounds and borders and shapes. And then all we really have to do is create our image request. This image request will take the data from our URL. We can crossfade it in and we can build it. And so most of the rest of this code lab is just going to be actually building that. But beyond actually setting the async image, the rest is just compose code. So we can put this async image in, play with some of those different arguments to get the features that we want. So in our case, it's going to include setting the content description, setting a content scale, adding a modifier, adding some error handling, putting an error handler, adding a placeholder. And once we do that, we display that image. From there, the final step of this code lab is going to be putting those in a lazy list. So in number 3, we learn how to display those images. And then we want to display them all at the same time. And so again, this is really a compose heavy section, which is going to be putting a photo grid, putting all our photos out there, and taking this photo item that we built in step 3 and just displaying all of the different images using that. And so once you work through all of that, they also add a retry button in case your internet is out. You'll get to the end. And from there, there's a lot of really good resources to learn more. And that is section 5 of downloading, learning about coroutines, downloading things from the internet, displaying images from the internet, getting data from the internet. I am happy to answer questions because we have just a couple minutes left.
Thank you so much, Sarah. Really, it was amazing. Sorry for my voice, I'm a bit sick. If we have any questions, please let us know in the chat. I didn't see any questions in the meantime. I checked the chat because you like told amazing things. So I think everybody got it. But if you have any questions, let us know. Otherwise, if we have like a couple of minutes left, I want to ask you some questions. I also asked some questions to Madonna too.
Sure.
I want you to know about like your Google Developer Expert journey. Not related to this, but if you're also open to that, maybe we can like talk about it also.
Sure. Yeah, I'm happy to. Sorry, I was trying to move screens around.
No problem.
Yeah. Is there something specific you want to know?
Yeah, like how you get into the program and everything. Like, what was the process for you?
Oh, sure. So I actually talk a lot about this here at Women Who Code because Women Who Code was like an integral part of my journey there. After a couple of years of really focusing on my career and myself, I decided like it was time for me to give back to the community. And so I started really small. I always started with mentoring people one-on-one because that was a really approachable way to kind of give back to folks for me. I still to this day struggle with presenting. It's very nervous and overwhelming for me. And so that was too much to kind of get started, even though I knew like long term that's kind of where I wanted to go. And so mentoring let me kind of practice talking about technical topics directly one-on-one to like people I trusted, and was giving something back to the community, hopefully helping their careers. And from there I could kind of build on that. So I did a lot of one-on-one mentorship, and then I kind of started. We had an Android study group in the mobile Slack for a while previously. And so I was running that and just kind of practicing topics again that I knew fairly well from being an Android developer for so long, and presenting those to the community and having that be a really casual setting before, again, taking the next step and starting to like present a little bit. And then from there, just continuing to do that. And I think the other piece that I always talk about is being part of the Women Who Code community and being the fellow for a year just helped immensely. It gave me an opportunity to talk to a lot of people in the mobile space and build some of those relationships so that people knew who I was, I knew who those people were, and I was invited to give talks and became a little bit more active in the Android specific community. So I kind of used Women Who Code to jump over and build up a lot of confidence around talking about Android development and sharing my knowledge.
Thank you so much. Thank you so much for your answering. And also, like, you're an amazing presenter.
Thank you. It took a lot of practice. But I always tell people that I'm very nervous. I still get very nervous.